Welcome to my channel Car Auto, ladies and gentlemen. Elon Musk's 2025 vision for robotics centers on the continued development and scaling of Tesla's humanoid robot, Optimus. First revealed in 2021, the project initially sparked curiosity and skepticism, with many wondering whether a car company could truly pivot into the realm of human-like robotics. However, by 2025, Tesla has made significant progress, not only in improving the capabilities of the robot but also in pushing toward mass production with ambitious goals that could reshape multiple industries. The evolution of Optimus from a conceptual demo into a functional and mobile humanoid robot marks a major step forward in Musk's broader vision of an AI-driven future. Tesla's Optimus Gen 2, unveiled in late 2024 and refined further in early 2025, represents a significant technological leap. This second-generation robot showcases improved walking mechanics, more fluid joint movements, and enhanced dexterity through newly designed hands and feet. Videos released by Tesla demonstrate Optimus navigating environments with a surprisingly human-like gait, suggesting breakthroughs in balance and sensor integration. The hands can delicately pick up eggs, handle tools, and perform tasks that previously would have required human-level motor control. With each update, Tesla closes the gap between robotic prototypes and viable, real-world applications. The ambitions for Optimus go far beyond novelty. Musk envisions a world where humanoid robots serve as general-purpose laborers, capable of working in factories, homes, hospitals, and potentially even on Mars. In 2025, Tesla is ramping up production, aiming to manufacture several thousand units by the end of the year. The company's internal roadmap outlines a plan to eventually reach a production capacity of 100,000 robots per month. This scale of output would position Tesla not just as a carmaker, but as one of the leading robotics manufacturers in the world. Tesla's AI advancements form the backbone of the Optimus project. The same neural network architecture and Dojo supercomputer technology used for Tesla's full self-driving (FSD) vehicles have been adapted to power Optimus decision-making. This allows the robot to learn from its environment, adapt to new tasks, and operate autonomously in unfamiliar settings. As Optimus continues to improve, its ability to function without explicit programming or remote control is expected to grow. The long-term objective is for these robots to be deployable across various industries without requiring bespoke programming for every task. Elon Musk has made bold predictions about the future scale of humanoid robots. He suggests that, eventually, there could be more humanoid robots on Earth than people, estimating a ratio of 2 to 1 in the distant future. This would mean a planet populated by 16 billion or more robots, each performing tasks that would otherwise require human labor. While some view these projections as extreme, they align with Musk's characteristic approach of setting ambitious targets and then working relentlessly to make them reality. His belief is that robots like Optimus could contribute over $10 trillion to the global economy, revolutionizing labor markets, supply chains, and even the structure of society. The economic implications are profound. By automating repetitive or dangerous tasks, robots like Optimus could reduce costs, increase efficiency, and free up human workers for more creative and strategic roles. For example, factories could operate 24/7 with minimal human intervention, homes could have personal robotic assistants, and hospitals could employ robots for patient handling, sanitation, or even surgery support. In agriculture, construction, and logistics, robots may take on the bulk of physical labor, changing the employment landscape permanently. Of course, the rise of humanoid robots also brings social, ethical, and regulatory challenges. Concerns about job displacement, privacy, AI control, and human-robot interaction are already being raised. Musk himself acknowledges the risks, emphasizing the importance of developing safe AI protocols and integrating robots responsibly into society. Tesla is reportedly working on fail-safes and ethical guardrails to ensure that Optimus behaves predictably and safely. Transparency in AI behavior and decisions is a top priority, and Musk has advocated for regulatory oversight as robotics continues to advance. The design of Optimus is rooted in practicality and cost-effectiveness. Standing about 5 feet 8 inches tall and weighing 125 pounds, it is designed to be strong enough to carry heavy loads but light enough to remain energy efficient. The robot's battery pack is meant to last for a full day of work, and its modular construction allows for easy maintenance or upgrades. Tesla is also developing software platforms that would allow users to train Optimus for specific tasks, similar to how apps are developed for smartphones. This open approach could foster a new developer ecosystem around robotics. Tesla's approach also leverages its existing manufacturing expertise. The company is using gigafactories to produce parts for Optimus, taking advantage of its vertically integrated supply chain. Lessons learned from car production. particularly in terms of robotics and automation, are being repurposed to scale humanoid robot production. This synergy gives Tesla a unique edge over companies starting from scratch in robotics. In 2025, Musk has emphasized that real-world deployment is the ultimate goal, and not just lab-based demonstrations. Consumer interest in Tesla's robot is growing, with many eager to see how it performs in everyday scenarios. Whether it's folding laundry, cooking, carrying groceries, or assisting elderly individuals, the potential applications are nearly endless. Tesla has already begun pilot programs to test Optimus in its own facilities, using the robots to move parts, deliver tools, and assist workers. Feedback from these tests is helping refine the software and hardware further, creating a feedback loop between development and real-world use. In addition to practical applications, Optimus also has symbolic importance for Musk's long-term vision of a multiplanetary civilization. He has speculated that humanoid robots could assist in building infrastructure on Mars, performing tasks in environments too hostile for early human settlers. This idea ties the Optimus project directly into Musk's broader goals with SpaceX, showcasing his integrated approach to technology and future planning. By creating versatile and self-sufficient robots, he hopes to reduce the barriers to colonizing other planets. In 2025, as Tesla continues to share updates and demonstrations, public fascination with humanoid robots is reaching new heights. The blend of sci-fi aesthetics and real engineering achievement is captivating audiences and investors alike. Other tech companies are also accelerating their efforts in robotics, partly in response to Tesla's progress. This competitive push could lead to a surge in innovation across the entire robotics sector, further blurring the lines between science fiction and everyday reality. While there is still a long road ahead before humanoid robots become a part of daily life for most people, the advances made by Tesla and Elon Musk in 2025 suggest that this future is much closer than it once seemed. With rapid developments in AI, robotics, and manufacturing, Musk's vision of a robot-filled world is steadily taking shape. Whether one sees it as a utopia or a cause for concern, there's no denying that Optimus is one of the most ambitious and potentially transformative projects of the 21st century. Please subscribe to my channel Car Auto.